Alright, so in this episode, we're gonna try to make a program to find out all of the divisors of even numbers, or even integers. So, for example, the divisor of 4 are 1, 2, and 4, whereas the divisor of 3 is only 1 and 3. Well, you know, the divisor of 6 got a 1, 2, 3, and 6, because 6 is a composite number. Whereas for a prime number like 13, the divisor is only 1 and 13 itself. So for the following exercise, so that we can check for the primality of a number to decide whether it is a prime or a composite number, we have to be able to find out its divisors. So today we're gonna write a program to find out the divisor of an integer. So the exercise will be write a Python program to find all the divisors of a positive integer. Okay, so we got on we got of an integer. So I'm gonna do a non-negative integer. Non-negative. So we will deal with the case of number 0 as well, which you can clearly see that 0 has infinitely many divisors. Actually, it is all the divisor except for 0 in the natural number set. So in this exercise, I'm not gonna deal with the negative number because that's gonna get really complicated. So yeah, and also I want to find out the divisor is also non-negative. Okay, so it's whether it's positive or it's, yeah, it is positive because nothing can divide it by 0. So for example, this divisor of number 4 is gonna be 4, 2, and 1, right? Because the divisor of 4. Divisor of 60. Okay, so 18 gonna be 18, 9, 3, and 1. Okay, so when we give the computer this input, we're gonna hope that we're gonna find that answer. So for example, divisor of a prime number like 17 gonna just yield 17 and 1. Okay, and for example, another prime number is 23 gonna yield 23 and 1 because it's a prime number. So for example, a more complex number, a highly composite number like 36 gonna yield 36, 12, 18 first, right? Because 18 first, and then 12, and then 9. Okay, then 6, then okay, wait, watch more. 3, 2, and 1. Right, so I think those are all. I think so. If we can find out more divisor of 36 that I have missed, the computer will tell us. Okay. Yeah, of course we are missing a 4 here because that was my miscalculation on my side. Okay. So let's write such a function. We want to write a Python program. So if we give the program the input of a positive integer, it's gonna return for us a list of divisor of that of that integers that we have given as an input. Okay, so let's write that program. So I'm gonna save this file as divisor2 first. Alright. So what is the strategy we're gonna explore in this situation? So okay, my strategy is that I'm gonna create a function which is equal find divisors. Okay, find divisors. Okay. And you're gonna take in the parameter a, which is gonna be a integer, right? An integer. So an integer, a positive integer. Okay, a positive integer. Okay. So first of all, let's look at the big picture first. When we enter the integer a, we want a to be non-negative. We want a to be non-negative because in this exercise we don't want to deal with negative divisors or negative numbers. So let's let's eliminate the case that a could be negative first. So we want a to be either be 0 or positive, and we're gonna deal with 0 right after this. So okay, so first of all we're gonna have an if loop to check if a is negative. So if a is smaller than 0, and then we're gonna just send out an error message. We're gonna return invalid input because we don't want to accept in negative input, negative integers. Okay, now with the elimination of the case of negative number, we have 0 and positive number left. So let's observe for the case of number 0. Oh, actually for the case of number 0, the divisor gonna be all the numbers in the natural number sets except for 0 itself. So what I mean is that 0 has the divisor of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. It's like going on forever except for 0. So it is actually all the natural number but for 0. So we have to make that a separate case as well. So if a equal to 0, and we have to make the comparison side, the comparison equal side, so then we're gonna return the divisor of 0 is all natural number except for 0. Okay, the divisor of 0 are all the natural number except for 0, because it's actually the case. Alright, now else. Okay, so L. Okay, so this is actually a LF. Okay, so LC. So L. Okay, so for all the other cases, which is means a is greater than 0, because we have checked the case of a is smaller than 0, and we have checked the case of a equal to 0. So the remaining case is actually a bigger than 0. Then let's think of the algorithm first before we check in. We write in. So for example, I'm gonna take number 6. So how you gonna find divisors? Okay, how you gonna find this divisor? So you gonna okay. So you know that the divisor here we are considering has to be from 1 to 6 itself, right? So we have to check for which number that's actually divided by 6 and we have to check for which number that is 6 is divided by that number, and that number has to be smaller than or equal to 6 itself. So okay, so we have to check in the list of number that is actually smaller than or equal to 6. Okay, so it's 1 2 3 4 5 6. So 1, okay, that's okay because that's the divisor of x. So check. I'm gonna pay a plus. Okay, 2, okay, that's a divisor of x because 2 times 3 is x. 3 is check. Okay, 4 is not check because this is not a divisor, right? I'm gonna just make a minus sign here, which is not a divisor, and 5 is not, and 6 is yes. Alright, 6 is yes. So you can see the algorithm there. We're gonna check from 1 to that number as to see which number is divisible by that original number. So let's make that code. Okay, so for I in range, okay, we're gonna check from 1. We wanna check from 1 to that number itself, but in Python index, the loop gonna stop one element before the ending that we designated. So we have to declare that number plus 1 as the end of the range, right? So in this case it is come from 1 to, okay, the number is a, so it's a plus 1. Okay, if a is divisible by I, because we had gonna divide it, we're gonna divide a for I, and 5 is remainder, so divisible means the remainder gonna be 0. So that percent size a modulus function to find out the remainder of the divisions. Alright, now so we want to find the number i's, right? Those number i's that gonna divide it by a. But now we also to append that number that we have found into a list, right? We have to want to put those results we have found into a list. Because otherwise the data when we print it out gonna be messy. So I'm not gonna create up here a divisor list, divisors list, and for now I will leave it as a blank list. But here, after we have found out the divisor, which is we found our number that the original number, the original input a is actually divided by that number. So we're gonna append that number I into the divisor list. So divisor list dot append I, because it is actually the divisors. Okay, you don't need future this. Okay, so now we want to return that list, right? Return just the divisor of AR, the divisor of AR, the divisors of AR. Okay, and we're gonna print out the divisor list. Okay, right. So that's the code. Let's have some check. Okay, so print find divisor of, okay, so we have a k of 6 here. Let's check if it's correct. So save and run. Oh wait, 1 2 3 6, so it's actually correct. Okay, so let's check some other cases. So for example, do we find for number 18, we have 18 9 3 and 1 in whatever order we're gonna accept it. So 18 and 5, let's check if it's correct. So run. So okay, 1 3 1 2 3 6 9 18, which is correct. Okay, so let's check some extreme case. Okay, so I want to check for the divisor of 0, and I also want to check for the divisor of negative 2 or negative 20, because we do not accept negative number, so it should return us an invalid input. And I also want to test for a big composite numbers as well. So 5 divisor of 120. Let's see, 120 large composite number. So okay, divisor of 120. Okay, a lot of divisors, so they actually split it all out, and it seems to be legit. 40 times 3 is 120, 60 times 2 is 120, 50 times 8 is 120. It's quite legit, you know. And the divisor of 0 are all natural number except for 0, which is actually exactly what we told the program to do. And also it also gives us the invalid input for the negative value here, invalid input. So this program works really well. Alright, so I think that's all for these exercises. This is the exercise to find integer divisors, positive integer divisor of natural numbers. So this is the program to find the positive integer divisors of natural numbers. So please check the code. So thank you very much. Yeah. Oh, I want to also check an extreme case, last extreme case, which is number 1, because if it returns us number 1, it's great. Okay, invalid input could end it's just 1. Okay, so that last case is also checked. So that's all. That's all for the exercise of finding divisors of natural numbers. Thank you very much. See you in the next episodes. Thank you.